Good evening, everyone. So we are back to the paper. We were on paper in the last class. Question number C10, section C10. As the switch is closed in the circuit shown on the figure, current pass through it is. It is a very important question. It is in fact a type of question. Draw the figure, draw the figure. We have like a wire coming here. Look at this. Draw the figure given. Right. All right. So what is given? We have a point from which a resistance is connected. This point is called A. And right here, we have another resistance, all right, which is connected to a switch S. And this is called ground connection or earth connection. Ground or earth connection, okay? Right. The bottommost point is connected to the ground. Ground or earth is represented in two ways. This is method number 1. This is method number 2. Lines of decreasing length. Okay. It is called ground or reference point, ground connection. Finish this. I'll explain it. Okay. Then what else is there? Another resistance is there. It's a standard question. Many times this has come. This is B. And this point is going to be called A. All right. And they have given the potentials of this. This is 20. Potential of this is 5 volts. This is 20 volts. This is 2 ohm resistance. This is 2 ohm resistance. This is 4 ohm resistance. All right. Tell me when you have drawn the figure. I'll tell you how to do such kind of questions. Done drawing this? So can you read the question now? If you finish drawing this, tell me please. Okay. Can you read the question? As the switch is closed in the circuit, current passed through the switch. I need to find the current passing through the switch. This is the switch, right? Switch, yes. First of all, let us look at the situation and draw the currents. Tell me, I have a current flowing from this potential. Current always flows from higher potential to lower potential, right? If you have 2 buckets of water with different levels, if you connect them through a pipe, water flows from where to where? Higher level to lower level. So water flows from higher level to lower level. Heat flows from where to where? Higher temperature to lower temperature. Similar way, the potential of ground is a reference potential. It is always 0. Reference potential. Whenever you see ground being represented this way, potential should be taken as 0. That is a standard reference. All right. So reference potential is always 0. Now, one thing is certain. Current flows from, this is higher potential, right? This is lower potential. 20 to 0 this way, right? I call that current by the name I1. Similar way, from 5 volt, a current is flowing this way, right? That current is called I2. And they join together at this junction to become what? I1 plus I2, or I call it I3. Okay. Now look at this. Did you understand my logic? This is higher potential. 20 volts is, I'll give you time to write. 20 volts is higher potential and 0 volt is lower potential. So current is flowing this way. For that one, 5 is higher potential, 0 is lower potential, current is flowing this way. So current flows from these two sides. They combine and they flow down like this. Okay, they join together. So tell me, you remember Kirchhoff's junction rule? I3 should be equal to I1 plus I2, or even otherwise it is common sense. This I3 is what? Sum of these two currents, right? This current is coming in, this current is coming in. They join together to become I3. I3 is equal to I1 plus I2. Okay. Now let us see this. I don't know the potential of this location. I call it X. Since it is an unknown potential, it is X. I know this junction, this point has a potential 20. This point has a potential 5. This point has a potential 0. So the only unknown point is this, right? I can call it X. Now tell me, what is I3? Current through this, right? How to write current? Voltage by resistance. Current is given by potential difference by resistance. That is what Ohm's law tells you, right? So for this one, can you tell me potential difference? Potential here is X. Potential here is 0. So potential difference is X minus 0 divided by resistance is 2 should be equal to. What about I1? Potential across this one, no? Potential here is 20. Potential here is X. Correct. So that must be 20 minus X divided by resistance there is 2 plus. Correct. What about that one? For this one, what is the potential at that end? 5. What is the potential at this end? X. What is the potential difference? 5 minus X. So 5 minus X divided by resistance there is 4. So let us simplify this. I'm going to take this as X by 2 is equal to 20 minus X by 2 plus 5 minus X by 4. I take LCM. LCM is 2, right? 4, right? I have to multiply everyone with the 2, right? Correct. So what does it become? First equation becomes what? Tell me. I multiply throughout with the 2. All right. I'm going to make 2. This is 2. This is 2. Or I take this as what? I can take LCM here, or you better cut with 4. That's better. 4. Okay, I'm multiplying throughout with 4. What do I get? 4 into, tell me, 4 into X by 2 is equal to 4 into, tell me what? 20 minus X by 2, because LCM is 4. I said 2 earlier, right? So LCM is 4. The greatest integer is 4, right? LCM is 4. So I must make this 4. I must make this 4, right? I'm multiplying throughout with 4. See what is happening. Plus 4 into 5 minus X divided by 4. 4 and 4 are cut, right? 4 and 2 are cut, it is 2. 2 and 4 are cut, it is 2. So what do I get? 2x is equal to 2 into 20, 40. 2 into x is 2x plus 5 minus x, right? I just expanded it. 4, 2 into x is 2x. Then 4, 2 into 20, 40. 2 into x is 2x. Then 5 minus x as such. I simplify this. Minus 2x comes to this side. Minus x comes to this side. What do I get? 2x plus 2x plus x. That will be 5x. Is equal to 40 plus 5? 45. X is equal to what now? 40 by 45 by 5? 9 volts. So I got the potential of this location. It is 9 volts, right? The question is to find this current I3. How to find current I3? Look at I3. It's X by 2, right? I3 is what? X by 2. X by 2, isn't it? X minus 0 by 2. I3, you have to find this I3. Current through the switch. Current through the switch is nothing but I3, right? How do I get I3? Tell me, I3. How do I get? This potential minus this potential divided by 2, isn't it? Correct. Potential difference divided by resistance. What is potential difference? Potential is 9 minus 0 by 2. 9 by 2, or it is 4.5. Is it there in the options? Answer is option A. Understood? Yes. So I've just drawn the figure again. I know only one thing. Reference potential is always 0. Reference potential means what? Potential at ground. Potential at ground is always taken 0. Got it? So we always give with respect to reference all the time. V is equal to 0. In bracket, reference. You write reference. That is called reference potential. Ground potential is also called reference potential. Then current is flowing which way? This is higher potential, right? 20, right? This is lower potential. So current is flowing this way, right? So draw that current I1. And there is a current flowing from that point to this point. That can be called I2. All right. Then they join together to become what? I3. Isn't it? Okay. And for this junction, I call the potential as X, the unknown potential. Put an arrow. Unknown potential. Unknown potential. Unknown potential. That potential I have no idea about, right? Okay. Now write by Kirchhoff's junction law. Do you know what Kirchhoff's junction law is? I haven't taught it yet, but you know this for sure, right? Or use simple common sense. Just imagine water is flowing. Water is flowing. Together they flow down. Right? It makes sense, right? I1 plus I2 put together constitute I3. Correct. So I1 goes to the right, I2 goes to the left. Together that would be I3. So write I3 is equal to I1 plus I2. I3 is equal to I1 plus I2. Now put the value. I3 is equal to I1 plus I2. What is I3? I3. Current is always, if you don't know, you must write current is equal to voltage by resistance. This is called Ohm's law. Okay. I'm going to write Ohm's law for this branch. Correct. What is the equation for current? Tell me, Sanya. Voltage divided by resistance. Current is given by voltage divided by resistance. Voltage means potential difference, right? Potential difference across this is what? Potential of this point is X. Potential of this point is 0. So potential difference is what? X minus 0 divided by the resistance there is 2 ohm is equal to. Correct. How about the second one? I1. Look at current I1. What is the potential difference? Left end is having a potential 20. Right end is having a potential X. So the difference is 20 minus X divided by 2. All right, at least some of you might have a confusion. Can't we take X minus 20? No, 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 no. This is higher potential, right? All right, right. This is higher potential. This is also higher potential in comparison with this because that will be an intermediate value. This potential will always be less than this and less than that as well. 100% sure. Okay. It's an intermediate potential, right? Okay. Right. So 20 minus X divided by 2 plus. Tell me what? For this part, how do you take the potential difference? That end is having 5. This end is having X. Correct. Obviously, 5 is bigger. 5 minus X divided by 4. Now multiply throughout with 4. I'm going to write it one more time. X by 2 is equal to 20 minus X by 2 plus 5 minus X by 4. I have intentionally left a space there so that I can multiply throughout with the 4. Am I correct? Correct. I am multiplying throughout with the 4. Tell me what you're going to get. 4 and 2 are cut, it is 2. 4 and 2 are cut, it is 2. 4 and 4 are cut. Now expand this. 2x is equal to. Multiply this into bracket. 2 into 20, 40 minus 2 into x, 2x plus 5 minus x. Get those x's to the left hand side. 2x is already there. Minus 2x comes to the left side to become plus 2x. Minus x comes to the left side to become plus x. 40 plus 5 will be 45. So this is like 5x is equal to 45. Or x will be what? X will be 9 volts. Okay, x will be 9 volts. So that is not my intention here. I need to find out. These are advanced level questions. Okay. One question that could decide your rank, maybe like 10,000 ranks. Understood? All right. Okay. Right. So this is what, if you don't know the technique, the question is very difficult. All right. So 9 volts is the potential at this location. My question is what? I need to find the current through this. I3. The question is to find the current through the switch. Current through the switch. Where is the switch connected? On this arm, right? Current I3 is how much? Tell me. I3 is equal to potential difference across this. Potential there is X. Potential here is 0, right? That makes it X minus 0 divided by the resistance is 2. Which is equal to X minus 0 is X. X by 2. 9 by 2 is 4.5 amps will be the final answer. Answer is 4.5 amps, option A. Second question, find the effective resistance. Find the effective resistance. One second. Find the effective resistance. Find the effective resistance. Find the effective resistance. Effective resistance is not there for boards anymore. Find the effective resistance between A and B. Find the effective resistance between A and B in the figure. Find the effective resistance between A and B in the figure. All resistors are. Find the effective resistance between A and B in the figure. All resistors are capital R each. Find the effective resistance between A and B in the figure. It's a previous question. Find the effective resistance between A and B in the figure. All resistors are capital letter R each. There are many ways to do it, but I just wanted to show you a method. There's something called mirror symmetry. I'll tell you. Find the effective resistance between A and B. Find the effective resistance between A and B. All resistors are capital letter R. Draw the figure. Tell me when you finish this. Done drawing? Okay, I'll tell you. This is a type of question where, look at this, where if you look at the right side, see the right side? The right side looks exactly similar to the left side. Look at that. I can draw a line through the middle. All right. Okay. For 1 second. I can draw a line through the middle. Look at this. See the line through the middle? If I draw the line through the middle, see this. I'll complete it one more time. All right. So if I draw a line through the middle, what happens? The right side looks exactly similar to the left side. Correct. This is called mirror symmetry. All right. The right side is the mirror image of left side. Mirror image of left side. Got it? It's a type of question. So how many questions I can show you now used on this, based on this method. Okay. Right. So if you draw a vertical line through the middle, right side and left side are similar. What you're going to do is you will cut the right side off. Look at that. Right side off. You will cut the right side off this part. All right. Cut the right side off the entirely. You will find the resistance of this, multiply that by 2. That's it. Because left side and right side are same, right? So find the effective of this, then multiply that by 2. All right. Now, before I do that, let me ask you, what is the resistance here? R. What is the resistance here? R. What is this? R. What is this? R. What is this now? R by 2, because half is gone, right? This is also R by 2. Am I correct? Now, another thing is, you can remove this line and tell me what? Connect these points together. They are all on the same line, right? They are all on the same line. They are all on the same line. So let me redraw the figure now. First, I have my A. All right. Okay. Then this resistance, the one on top. This resistance, the one at the bottom. Right. From there, these two are in what? Look at that. The left ends are connected together. Right ends are connected together. Right. For this resistance, where is the left end? This location, right? For this resistance, where is the left end? Look at those resistances. Look at those resistances. These points, no? See, they are connected between them in parallel, right? Correct. So I'll just replace them, R and R by 2 with, tell me what? That will be R into R by 2 by R plus R by 2. Parallel is R1, R2 divided by R1 plus R2. R into R by 2, R square by 2. R plus R by 2, 3R by 2. R and R are cut, 2 and 2 are cut, R by 3. So I can replace that with R by 3. Similar way, look at these two together. Same thing now. So they will be replaced with a single R by 3. Now what? These are in series, right? Correct. These are also in series, right? Then they are in parallel, right? Multiply that by 2, you have the answer. Got it? No? Let's do it from the beginning. Okay, let's do it from the beginning. All of you online? I'll draw the figure one more time. It's very difficult to draw the figure again, but I'll draw it. Okay. All right. So let us draw the figure. First figure you have drawn, it seems, right? All right. This is the first figure. I have like I said, there are many ways to do it. This is one of those shortcut methods. Draw the figure. We have, this is basically like two Wheatstone's bridges. You can use that method, or many such methods for that matter, right? So just draw the figure this way, right? First figure you have to draw this way, then draw a line through the middle. Draw a line through the middle. I didn't ask whether you understood or not. After this, I'll ask you, okay? Draw a line through the middle. Yeah. Draw the line through the middle. Now, this is called mirror symmetry problem. You can write mirror symmetry. Mirror symmetry means what? The right half looks exactly similar to first half, left half, right? Right side and left side are identical, right? Cut it into half, wipe the second part off. You can write wipe second part off. Wipe second part off. Oh, you can't see it. Wipe second part off. Okay, I'm going to do that now. All right. So let us write those resistances. This is R, this is R, this is R, this is R. All are given, right? This is R by 2. Okay. R by 2, half of the resistance. No. What if we have a resistance here on this line? That will be 0. That won't be taken. That will be because this line will have same potential everywhere. So that resistance will be neglected. Got it? In case you have a resistance on this line, you just get rid of it. Got it? So once you have done this, just wipe the second part off. Wipe the second part off. So redraw the figure like this. Redraw the figure like this. Maybe without this vertical line as well. Redraw the figure. Now I'll just use another color to connect this. Now these points are to be connected. These points are also to be connected. Got it? Because those lines are at same potential. Same potential points can be connected, isn't it? Right? This point, every single point on that line, virtual line, are at same potential. Is at same potential, understood? So you can just connect them. All are connected, okay? So redraw the figure this way. I used another color so that you can easily understand. So you have to redraw the figure. After first figure, put an arrow, then draw this figure, okay? Understood until here, all of you online, everyone? I'm going to ask you to do the next question on your own. Everyone, there's very high chance of coming, okay? All right, Kripa, Daniel, Srihari. All of you, please, I'm asking the whole class. Finish this now. Now, what kind of a combination these are in? They are in what combination? They look at the left ends of those resistors. Left ends are connected together. Right ends are connected together, right? They are in parallel. So you can write, they are, put an arrow and then write parallel, right? Okay. Okay. They are in parallel, right? I'm going to replace, but I have to find it first. R parallel R by 2. How do you do that? R into R by 2 by R plus R by 2. Did you understand how I got it? R1, R2 divided by R1 plus R2. Parallel combination, you learned that in class 10. Class 12 boards, you don't have it, but still they might ask R1, R2 by R1 plus R2. What am I getting now? That's like R into R by 2, R square by 2, R plus R by 2, 3R by 2, R and R are cut, 2 and 2 are cut. You are getting R by 3. You have to write one more thing. These are also in parallel. You know why? Because left ends are connected together, right ends are connected together. Understood until here, everyone? Now let's get to the last of. Now you're going to draw one more time. So you're going to replace these guys with a single resistance. I'm using another color, okay? I'm using green color for it, okay? What is its value? R by 3, right? Similar way, I'm replacing these guys with another R by 3. See how simple the configuration is now? R by 3. Got it? Okay. Now tell me what. Let's get to this. Now it's very easy. Next figure you can draw. R and R by 3 in series, no? R and R by 3 in series, no? R and R by 3 in series is what? R plus R by 3. R1 plus R2. R1 plus R2. 3 comes here. 4R by 3. So I have a 4R by 3. Which is that? This 4R by 3. Understood? 4R by 3. Got it? Similar way, these two together is also what? That is also 4R by 3. Correct? Got it? Now, how about those two? 4R by 3 and 4R by 3 are in what kind of a combination? They are in parallel combination. The moment you see it, you have it, right? They are in parallel combination, isn't it? Isn't it? So, what is R effective? R effective is equal to 4R by 3 into 4R by 3 by 4R by 3 plus 4R by 3. But there is a shortcut there as well. If they are identical, divide that number by 2. Number of resistors. If they are identical, no? 4R by 3. You try that calculation out. You will get what? 4R by 3 by 2. Answer will be 2R by 3. Check if it is correct. 4R by 3 into 4R by 3. 16 R square by 9. By 4R by 3 plus 4R by 3. 8R by 3. 8 and 16 are cut 2. R and R are cut. So 9 and 3 cut, it is 3. So it is 2 by 3 times R. That is exactly what I got here, right? Correct. For identical resistors, we have a shortcut. If you want, you can write that shortcut. Instead of doing all those calculations, you simply take it that way. R parallel is equal to resistance of 1 divided by number of resistors. Resistance of one of them. For example, if 10 ohm are connected in parallel, it is 10 by 2. 10 ohm are connected in parallel, 10 by 3. 10 ohm are connected in parallel, 10 by 4. 10 ohm are connected in parallel, 10 by 5. 10 ohms are connected in parallel, 10 by 10. If identical resistors are connected in parallel, you can use that shortcut, okay? Right. Value of one resistor divided by number of resistors. Value of one resistor divided by number of resistors. Now, this is 2R by 3. Am I completely done? No. This is only half, no? I wiped one half out, right? So, you can write final resistance or simply write RAB. They are asking between A and B, no? I said I did only left half. Right half still remains. So, I must take 2 into 2R by 3. That's going to be 4R by 3. All of you got that? Let's do question number C7. Can you draw that figure? C7. We have a resistor here. We have another resistor here. Then another one here. Another one here. Right. And similar thing there. Another one there. Another one here. Another one here. Right in the middle, we have like another resistance. And from here to here, we have another resistance. Draw the figure, I will tell you how to do it. Frequently asked question, okay? All resistors are R. This is A, this is B. The moment you say this, you know that this is a mirror symmetry question, right? Correct. Tell me when you finish drawing this. We'll get another question in the meantime. I don't have that question. Okay. Okay, fine. So what about this? Like I said, this is again a mirror symmetry question, right? So draw a line through the middle like this. Draw a line through the middle. All right. Okay. And I had told you that the resistances on the line can be neglected, right? I'm just wiping the second part off. The left side and right side are exactly similar to each other, isn't it? Isn't it? So right side can be wiped off. I'm just wiping the right side off. That's of no use to me. All right. Okay. Now the figure looks much easier, right? I can remove this as well, the line. Even this resistance, right? Even that resistance. So I got a figure like this. Instead, I'll connect them through a straight line. These points are all connected, isn't it? Tell me about this. This is R, right? This is R, right? This is also R. How about these two? R, R. This is also R, right? What are you going to do now? Look at this, these two together. What are they in? Series combination, right? Only one path, 2R, right? So let me draw that here. Same thing, no? I'm going to replace that with a 2R. Okay? There is already an R here, this R. All right? Yes, Ajit. Got it. Did you understand what I did? Look at this, Trivi. R and R are taken in series now. So R plus R, 2R. This R will be as such. Correct? Similar way, I have like these R and R. Look at the green ones. These R and R together will be what? Will be a 2R. The same way I can write. This is 2R, right? And then what? This R, that R will be written as such. Correct. And as always, these points are same, right? Correct. I can call this point B, this point A. Can you tell me where the left end of all resistors are connected? Left end of 2R is connected to A. Left end of R is connected to A. Left end of R is connected to A. Left end of 2R is connected to A. Where is the right end of A connected? 2R connected to B. Right end, look at that. It's bent and it is connected to B, no? Right end is connected to B. Right end is connected to B. Right hand is connected to B. Or imagine you are walking from A. Look at that. You can travel through all the resistors, right? You can walk along this resistor, you reach B. You can walk along this resistor, again you reach B. You can walk along this, you would still reach B. And walk along the last path, you reach B, no? Multiple paths means they are all in parallel, right? Correct. Finally, they are all in parallel. All in parallel means how to find 1R, 1 by R. 1 by R is equal to 1 by R effective is equal to, tell me what? 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Or you can use the shortcut. 2R and 2R in parallel, 2R by 2. Earlier I gave a shortcut, right? R and R parallel, it is R by 2. Then you can take them in parallel. Or take it this way, the direct method. 1 by R is equal to, tell me what is 1 by R? 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, right? Now, so tell me what LCM is? 2R. So this is 1 itself plus this becomes 2, right? When I take LCM, this becomes 2, right? Plus this also becomes 2. This becomes 1. 1 by R effective. So that is what? I'll clear your doubts after this. 1 plus 2, 3. 3 plus 2, 5. 5 plus 1, 6. 6 by 2R is equal to 1 by R effective. So R effective is what? Take the reciprocal. 2R by 6 is equal to R by 3. Yes, that's correct, Yajat. Very good. R by 3. Did you Google it, Yajat? R by 3. So, but this is only half, right? Why? I wipe the second part off, right? So you can write R final. R final is equal to 2 times R by 3. So 2R by 3 will be the final answer. Answer is option C. Find the effective resistance. Find the effective resistance. It's a previous ITJ question. I don't remember the exact values, but I'll try though. Find the effective resistance between A and B. Yeah, very good, Lakshana. Right. First thing is what? You have to draw the vertical line, right? You have to draw the vertical line. I'm drawing the vertical line. This is again a mirror symmetry problem where I draw the line through the middle. Look at the line through the middle. All right. I'm wiping the second part off. All right. Okay, second part off. Got it? Second part is gone. Understood this? Then this part is also removed. The line also removed. And all resistors on the line can be removed, right? All the resistors on the line can be removed. Then you can connect them in parallel. Those points can be connected, right? All those points are at same potential. The question was a little different. Anyway, it's a previous ITJ question. Question was not this easy anyway. But anyway, let's see. Because if you don't use mirror symmetry, it's very difficult. You can't do this question very easily. Okay, these kind of questions. So 2R. First is what? You take the identical ones. That will make your job easier, right? 2R and 2R in parallel. Can you tell me what? 2R parallel to 2R. I had told you that there is a shortcut. Take one resistance divided by number of resistors, right? Check it again, Lakshana. Right. 2R and 2R in parallel, it's going to be R, right? R, right? 2R by 2. How to find the effective of these circled ones? Take the identical ones first, okay? Identical ones, that's, or you use 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. I'm trying to save time for you, that's what. Okay. Okay. So what about this one? First resistance 2R, second resistance 2R. Identical ones, no? Identical ones, resistance of one resistor divided by number of resistors. 2 and 2 are cut. So finally I get R. That R is in parallel with, look at this yellow circle, this R, right? Correct. These two are already in parallel. You find their effective. That's in parallel with this. Got it? So tell me what you're going to get. So R, these two in parallel is capital letter R. Parallel to small letter R is what? Ah, yes, that's correct, Lakshana. Because I didn't think about the second part. RR by R plus R. That's right. I'm really sorry. Ah, yes, Lakshana, that's right. Left side is RR, Daniel, correct. RR divided by R plus R. Left side is RR by R plus R, right? So what is R final now? I have taken only the left half, right? How about the right side? 2 times this. 2 into RR divided by R plus R. 2 RR divided by R plus R. Hope all of you got it. All of you understood this? All right, so let's do one more question. That's again a tricky question. Can you see C8, C6 on the paper? Draw the figure. That's a multiple times asked question. Now it can come in boards also. That's again a tricky question. Make sure that you draw correct number of branches. Second one, then the third one, then the fourth one. Okay. Then I put a small gap there. Then how many more I have to draw? 5 more, right? 1, 2, 3, 4, 5. Here I connect an ammeter. Draw the figure. I'll tell you how to do this. This is 9 volts you're giving. All resistors are 9 ohms each. You have to find the ammeter reading. This could come in board exams also. Okay. That actually falls within the scope of syllabus. Next class, I'll finish this paper. I'll move to second part of current electricity, which has a lot of questions for boards also. All right. Kirchhoff's law questions. Please do not miss the next class. It's a request. Cut horizontally, that type of question is not asked anymore, but I'll do it. Tejas, since you asked. Next class. Vertical line, all the points are at same potential. We are using that technique to solve these kind of questions. Cutting horizontally is actually meaningless here. But there are methods to do questions like that as well. Okay. Already finished this? I'll tell you how to do the question. Okay. Do not go into too much into this. Do not dig too deep into this. I can tell you with simple things, you know. How many resistors are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? All of them are identical, right? So what is R effective? Value of a single resistor divided by number of resistors. Am I correct? All are identical, no? All are identical. All are in parallel. How do we know they are in parallel? Because where is the top end connected? Top end is connected to positive of cell. Where is the top end of this connected? Positive of cell. Top end of this is connected positive of cell. Top end is positive. Top end 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 positive. All the top ends are connected to positive. How about bottom ends? Bottom end is connected to negative. Bottom to negative. Bottom to negative. All, see, basically all these resistors have their ends connected directly to the terminal. Got it? So what is it? So all are in parallel. For identical resistors, what is the equation I told you? Shortcut. Identical resistors. Tell me what you're going to write. Effective is equal to R by 9, which is 9 by 9, which is equal to 1 ohm. The effective is 1 ohm. Got it? What will be the current then? Current is V by R, no? When I say current, the first thing that comes to your mind is, should come to your mind is Ohm's law. So voltage is how much? 9. By current is how much? Resistance is 1, which is 9 amps. So let us analyze the situation. See, 9 amps current would leave this positive, right? Tell me what? When it sees here, 1 amp goes this way. Ask me why. Ask me why. Symmetry, no? I have 9 branches, so 9 amp current would be equally split. I have the right to believe so, right? Correct. 9 ampere current going into the junction. 1 ampere goes this way, 1 ampere goes this way, 9, 1 goes this way, this is 8 now. Correct? Correct. 9 ampere goes this way, when it reaches junction, 1 ampere goes this way, then rest is 8. From 8, 1 goes this way, this will be 7. 7 reaches junction, 1 goes this way, this will be 6. From 6, 1 ampere goes this way, this will be 5. From 5, 1 ampere this way, this will be 4. Correct. Then from 4, 1 this way, this is 3. From 3, 1 this way, this is 2. From 2, 1 passes through this branch, this is 1. Correct? Right? Now what? What's happening? That 1 is coming here, right? This one is joining it, right? This one is coming here, this one is joining it. Together that will be 2, right? 1 is coming through this. This is 1. Then 1 is coming here. 1 and 1 together, 2. 2 comes to the junction. Then 1 is coming down from the top. 2 plus 1, this will be what? 3. Then 3 plus 1 comes here. What will be that? 4. 4 plus 1 comes here. What will be this? 5. So the ammeter measures how much? 5 ampere. Ammeter current passing through the ammeter is what? 5 amperes. Then let us check here. 1 ampere comes here. This is 5. This will be how much? 6. Then 6 comes here. 1 comes here. That will be 7. 7 comes here. 1 comes here. That will be 8. 8 and this 1. That together that will be 9. 9 ampere left the cell. 9 ampere came back to the cell. That's it. Now they can ask, put the ammeter anywhere they want. Look at this. What if they put the ammeter right here? It will measure 3 ampere, right? Understood? Now you know find the current. Wherever they put the ammeter, you can find the current. All of you got this? I'll do this one more time. All of you got this? No? No one is responding. I'll do it one more time. Okay, let's draw the figure one more time. Draw the figure. This is like a cell. Don't worry, I'll help you with it. Okay. Now this is like one resistor, second resistor, third resistor, fourth resistor. After 4 resistors, you leave a gap. Am I correct? Leave a gap and then 5 more to go. Not sure if I'll have the sufficient space there. So this is like a meter. That is where they have connected the ammeter. This is 9. All of you understood this? I'm asking the whole class. Tell me. The first thing is what? R effective. Find the R effective. Find R effective first. R effective. It's a type of question. Same question will come as such. Understood? This is a repeated one. If you don't trust me, you can check. R by 9. There are 9 resistors. All are in parallel. There are 9 resistors altogether and all are in parallel. How do we know all are in parallel? Because all resistors, one end is connected to positive. All resistors, other end is connected to negative. They'll give in parallel only. That's a typical question. Got it? These are all typical questions. Okay. Right. Will be asked as such. So all are in parallel. Effective will be, shortcut I told you, resistance of a single resistor by number of resistors. Resistance of a single resistor by number of resistors. So 1 ampere. Oh, 1 ohm. I got the resistance as 1 ohm. Effective resistance is equal to 1 ohm. Am I done? Not yet. I have to find the current, right? Main current. Write the main current. You can use Ohm's law. V by R. Voltage is 9 in the question. 9 in the question given. Look at this. Look at this. 9 by 9. Oh, no. 9 by 1. So that makes it 9 amperes. So my main current that is leaving the cell is 9 amperes, right? I am giving 9 reals to 9 students. I should be impartial, right? So everyone should get same amount of money, right? Same way. All are identical resistors, so everyone should get equal share. As simple as that. Understood? So 9 ampere current distributed among 9 components will be 9 by 9, 1 ampere, right? Everyone should get equal amount, right? Everyone has the right to equal amount. Am I correct? So 9 ampere flows to this junction. Let us analyze one by one. 1 ampere will go this way. So this will be 8. 9, 1 this way, that is 8. Reaches the junction, another one, this must be 7 then. Correct. Again flows to the right, reaches the junction, this will be 1. 7 minus 1 will be 6. Correct. All of you online got this. From 6, reaches the junction, 1 goes this way, that will be 5. 5 goes to the junction, 1 goes this way, that will be 4. 4 goes to the junction, 1 goes this way, everywhere 1 will go. So that will be 3. Now here 1 will go this way, this will be 2. 1 will go this way, that will be 1. What happened? What happened? Tell me. No. How can you cut? How can you cut? Number of resistors, how many? 9. No, is that symmetric then? Equal number? No. All right. Symmetry problems, when you see it, you'll understand. This kind of questions will come in symmetry. When the moment you see this, they look symmetric. The moment you see it, you will feel it is symmetric. All right, there are 4 or 5 type of questions here. Understood? Now, it's not about finding effective resistance as well. This question is about finding current through each branch, no? Okay. But because finding resistance is very easy, you don't have to use symmetry. All are equal, all are in parallel, 9 by 9, 1. Straight away you'll get it, no? Okay. So 1 ampere. Now what? This 1 ampere is coming down. This is 1. That one comes to the junction. Then right as it reaches junction, 1 comes from top. 1 plus 1, 2. Then 2 goes to the left. Then 1 is coming down from the top. Together that will be 3. Correct. 3 reaches junction. 1 comes to the junction. 3 plus 1, 4. 4 and this 1 together, that will be 5. Okay. So let us do it completely. And 5 comes here, 1 here, that will be 6. 6 and 1 here, that will be 7. 7 and 1 here, that will be 8. And the last branch will have 9. They are asking which current? This current, no. So current in the ammeter is 5 amperes. Is that there in the options? Option A. And right and not. In the question, the ammeter can be put anywhere. The ammeter can be put anywhere they want. By they, what I mean is the one who sets the paper, right? The ammeter can be put anywhere they want. Now you get the answer, right? If they put it here, it is 3 amperes. If they put it here, 4 amperes. If they put it here, 7 amperes. Here, 8 amperes. Here, 1 ampere, right? Got it? Wherever they put, you have the answer to this. Understood everything we learned today? Shall we wind up for the day?